I'm Terry Coleth, and I'm here today to share some interesting educational tidbits with you about all things eclipse. Our guide today is going to be Doug Heatherly of Royal Bonnet, an astronomer and someone who has taught and leads the astronomy club here at Shell Point. Thank you for joining me, Doug.
My pleasure, Terry.
Well, you and I have agreed that there are pretty amazing things going on in the world today, but nothing as amazing as what happens in nature.
That's correct.
And something big is coming up in nature, an eclipse. And I just wanted to talk a little bit about it because it's such an exciting thing coming right here to us. And let's start with what is an eclipse?
Okay, first of all, the eclipse they're going to be talking about is August 21st. It's when the moon moves in front of the sun and basically blocks light from the sun. And essentially the whole continental United States, the lower 48 states, are going to see at least a partial eclipse. And a good part of the country is going to be able to see what we call a total eclipse.
And you will be one of the people.
And I'll be one of the people, yes, with good Lord providing on that.
That's wonderful. So why is this so rare, Doug?
Actually, eclipses are not rare, okay? Eclipses occur probably at least twice a year, as often as probably 6 or 7 times a year, somewhere in the world. But you have to remember, the world is mostly water. 70% or so of the surface of the earth is water, and much of the rest of the world is really not accessible. I mean, you go across some portions of Africa, some portions of Asia,
right.
You can't get to it. And so eclipses don't take a preference of where they light. The one that's so significant this time is the fact that it goes across the entire continental United States and is going to be accessible to probably over 100 million people within 2 to 3 hours of the total eclipse, somewhere, yes.
So tell us why this doesn't, what makes it happen when it happens?
Okay, what happens is it's the shadow of the moon as it traces across the earth. It turns out, astronomically, the moon and the sun are significantly different sizes. They just happen to appear to us to be the same size because of the distances they are from us.
Right.
Okay? So as the moon moves in a direct path across the orbit of the sun, as it comes across, it'll cast a shadow, and when that shadow crosses land, like it's going to do on August 21st, we'll see the eclipse happen. So you'll see the sun start blocking out. Most of us will see what we call a partial eclipse. In other words, you'll see only part of the sun blocked out, which makes it a little interesting as far as observing.
And it makes it a little dangerous too, doesn't it? Let's talk about that.
That's
Tell us about that.
Okay. What you need is what we call eclipse glasses. Okay.
And how do you get these?
Okay, you can get them. There'll be some local stores. I think Lowe's probably has some, and some of the other local stores will have some. But what you need to pay attention to is that, one, it has some information on it that will tell you that it's safe for solar viewing. And there's also ought to be an ISO certification number on it.
Got it.
Okay, and these particular paper glasses will have that. By the way, a number 14 welding glass will also work.
Really?
Okay. What you really want to do is, it's not only the brightness you're talking about ultraviolet light, infrared light, that actually will damage your eye if you stare at the sun. Or
These are very dark. You want to put them on when you're standing somewhere.
You have to put them on, and you use these during the partial eclipse.
Okay.
And all we're going to see here at Shell Point is a partial eclipse. Although the partial eclipse will be 75 to 80% of the sun will be covered.
And that's almost more exciting because you see that brightness all the way around. You'll see the brightness,
yeah, that's exactly right. Yes.
Very exciting. So we get our glasses and we put them on and we just watch it happen. What is another way? You said
you might remember back in childhood, okay,
yes.
when we would have an eclipse, and we would take a cardboard box and we'd punch a pinhole through it and then project through that. It's an old camera trick. Project to some bright, like a white piece of paper.
Right.
And you'll see the image of the sun, and you'll see the moon image on that projection.
I remember doing that at school.
You can do that, and it's probably the safest way to observe. What you absolutely don't want to do is use binoculars or
Right.
something like that. Okay.
All right.
Yeah.
So we're watching this. It's going to be pretty fantastic. Is there anything that scientists take away from these experiences?
Oh yes.
What kind of things?
Let me give you personal experience on that one.
All right.
The first solar eclipse I went to was 1972. Okay, and it was a science expedition, and our team from the university went to north up on the Gaspé Peninsula, mouth of the St. Lawrence Seaway. What we were doing at that time, and this is how far science and astronomy has advanced in the last 50 years, I guess. But we were looking for radio, we were correlating radio waves with optical images on the sun. So we were looking to see what was causing radio emissions from the sun and whether it was coming from specific locations like sunspots or something else that we could see. So we used the moon as a shutter, basically. And as the moon would come across, we would take pictures, and we had a radio telescope observing at the same time, and we were trying to correlate the two pieces. That was pretty amateurish in today's world, okay? But you're still doing what you can see in a total solar eclipse that you can't see as a rule is what we call the corona, which is the outer atmosphere of the sun.
Okay.
And it's sort of interesting because the sun, the surface of the sun's about 6,000 degrees or so, but the corona is in the millions of degrees. And one of the things that scientists still puzzle over is why is that the case? And one of the wonderful things about the total eclipse, which you have to be in a very narrow band because a total eclipse is only about a shadow of maybe 100 miles across, okay? And it only lasts, if you're in one location, it only lasts about 2.5 minutes this time, okay? The shadow will actually, you can see the shadow moving across, coming towards you, and as it takes off, and it's moving at about 2,000 miles an hour.
What must people have thought in primitive times without any information?
You can read some stories, but usually that either the gods were favorable to them or the gods were unfavorable, depending on which side of the battle they were on.
Must have been terrifying.
It was.
Wow.
It was.
And now terrifying is an interesting word because now it's awe-inspiring.
It's awe-inspiring.
Amazing.
And like I said, this time, this eclipse is going to be accessible to an enormous number of people. And the actual band of totality will start in Oregon and will progress across the United States. It'll hit locations such as Jackson Hole, Wyoming. It'll come across Kansas City, Missouri, Nashville, Tennessee, Greenville, South Carolina, Charleston, South Carolina. One of the issues that you always have with these, though, is that they last a short period of time, and if clouds get in the way, it can mess the story up. And clouds are a real issue, only because the temperature will drop when the moon starts interrupting the sun. And so it will cool the air down and condense moisture out so you can get clear till you almost get to totality, and then it could cloud out. So areas that have lots of moisture are vulnerable to a lot of clouds.
Darn.
Yep.
Well, we'll do the best we can with what we get, and we'll have our glasses and we'll be ready.
That's right.
And we certainly hope that you will not only enjoy this great information from Doug Heatherly of Royal Bonnet, but that you will take some time with your special glasses to actually go out on August 21st and enjoy the eclipse.